Coming up on This Week in Radio Tech, Chris Tobin joins me. We're talking about stealthy antennas from those tricky mobile carriers. Can you count on mobile data bandwidth now or in the future? Sun transit fade on a terrestrial microwave path? And a better Ethernet switch is going to solve that problem for you. Coming up on TWiRT. This Week in Radio Tech is brought to you by Lavo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. By Direct Current, the weekly broadcast technical newsletter from the Telos Alliance. And by the Axia Fusion AOIP mixing console. Fusion is the Axia modular console packed with features refined from over a decade's worth of IP audio experience. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, delighted to be here on this hot summer day. It's hot all across the country. It's humid in a lot of places. It's hot. We are in what a lot of folks call the summertime blues, where you just don't feel like getting out and doing stuff. What, is this a show about the weather? No, it's This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower, and now so much more in between. We're going to hit a bunch of little topics today as our guests are us, Chris Tobin and me. Speaking of Chris Tobin, he's high atop some skyscraper in the New York City area. Hey, Chris, welcome in. How are you?
I'm doing well. I'm on a rooftop. Yes, I'm not that high up, and it's not a skyscraper. It's more of a low-rise building. But I'm outdoors today. I was going to do something using wireless municipal Wi-Fi, but it didn't go as planned.
For us guys in the middle of the country, any building in New York must be a skyscraper. So
okay, fair enough. Yeah, you know what? I have relatives out in the Midwest. You're absolutely right. When they come to visit, they are in awe of the 6-story buildings around us. Yes, absolutely.
Yeah, there you go. 6-story. Yeah. So I'm sorry, I interrupted about municipal Wi-Fi. What was that about?
Oh, I was planning on today, because it's such a nice day and the blue sky, there would be nice contrast and the sunlight. I was going to utilize the municipal Wi-Fi across the street in the park. However, as I was getting ready to set up, I noticed a small truck and 2 gentlemen walking around with what looked like a spectrum analyzer, portable Aritsu. I'm going, okay, this can't be a good sign for me. For them, it's probably all right. So I went up to one of them, explained to them what I do, and they're like, oh, yeah, and I understood what they were doing. I said, are you guys going to be turning on and off and changing bandwidth on the Wi-Fi? He's like, yeah, we're actually changing out the access points and making some changes to the signal coverage. I was like, okay, plan B, going wired today. So I'm on a battery, laptop, wired connection, and on a rooftop. So that was plan B.
So you're wired, what, down into the building somewhere?
Down into the building, yes.
Okay.
Dropped a nice 200-foot Ethernet cable down the side into a window and into a switch, and here I am.
See, when I think of you outside on a rooftop doing a live remote like you do so often, I figure that you're probably got a ubiquity hotspot with a directional antenna about 8 blocks down the road, and you're bouncing it like a pool, like a cue ball, from one building to another down the avenue and arriving at your location on a rooftop somewhere. But that's not what you're doing today.
No, but funny you should say that, because in the upcoming weeks, I am currently in the process. I've got the parabolic dish. I've got the ubiquity radio that's going to screw into the back of it, and I will be bouncing a signal, 5.8 gig, off a building across the way, glass building. Hopefully, if the angle is correct, because I can see the building rooftop I'm going to be on. So I'm actually use the reflection of the building I'm going to be on against the building I'm going to use as a reflector, and hopefully be able to receive this signal using 2 ubiquity radios. So I will be bouncing a signal just to try this out, just to prove that you can do things if you plan it and have imagination.
And you're going to do it without the traditional TV fly swatter.
That's correct.
Yeah. Use the building as your fly swatter.
Exactly.
That's cool. That's cool.
Yeah.
Boy, we got a lot of inside baseball on this show. But you engineers who are watching, you know what we're talking about. This Week in Radio Tech is brought to you in part by the folks at Lavo, L-A-W-O, and they are the makers of this crystal clear audio console. Let me tell you about that for just a second, as the folks at Lavo very politely and nicely sponsor this part of our show. Everywhere you go, you know, you find touchscreens nowadays. There's your smartphone. There's tablets, of course. Supermarket checkouts have touchscreens. Laptops, lots of them come with touchscreens. My son opens a magazine and starts touching it, wanting the pictures to change. No, you got to get the They got to get the iPad for that. So even airplane cockpits have touch screens nowadays. They make sense because they're simple and natural. And if the software's well designed, they really do increase efficiency and accuracy in using that device. Well, the intuitive controls can help make all your tasks faster with fewer errors too. So maybe it's time to bring the power of a touch screen to your radio studio. Well, you can do that with the crystal clear virtual radio console from Lavo, L-A-W-O, Lavo. Crystal Clear gives talent an instantly understandable multi-touch interface. You get faders, meters, clocks, timers, talkback, and more. They all live in harmony on that single screen. So shows run smoother and they sound better. And by the way, the screen can be huge if you like. Crystal Clear features Lavo's exclusive Auto Mix, the hands-free smart mixing algorithm that's actually designed for fast-paced multi-mic talk shows. Yeah, you can let it mix by itself. And auto gain. You push a button, the preamp calibrates automatically while your guest is speaking into the mic. And oh, is that a problem solver? With so much advanced automation, talent can dock those mixing controls over the side and then use the screen for other things like working with delivery systems. Yeah, bring up your automation there. Audio editors or even phone systems. Crystal Clear's power plant is just 1 RU in size. That's amazing when you consider the staggering amount of DSP on board. They have compression, EQ, voice processing, and precision delay. Those can be applied to all of the mic, line, and digital sources. Optional upgrades include redundant power, MADI, and Ravenna and AES67. All of this power costs no more than you'd spend for an ordinary board. So if you're thinking of a new console, don't decide before you check out Crystal Clear from Lavo. You go to www.lavo.com and read about it. Or call in the U.S., call Bill Bennett at Lavo USA. Bill's number is 888-810-4468. 888-810-4468 to find out more. The future is clear. It's Lavo Crystal Clear. By the way, if you happen to be in the Nashville area, about this time next month, the first Thursday, which is the 1st of September, Bill Bennett is going to be speaking at the Nashville SBE meeting. So if you're in this part of the country, feel yourself welcome to come and listen to Bill Bennett give you an update about Lavo and what they're doing for radio broadcasters. All right, Chris Tobin is with me. We've got a potpourri show here, and tentatively calling it Summertime Blues. Chris, what has been on your mind lately? I got a few things that have been on my mind. You and I talked earlier today, but there's plenty to worry about, think about, do about in the world of radio engineering during the summer. So what's on your mind right now?
Well, I've been doing a lot of outdoor broadcasts, outside broadcasts, and doing things with friends and helping folks out, both in those who are broadcasters and those who are netcasters. So, those on the internet and those over the air. We'll separate the two. And I was recently, pondering while sitting in a park and looking at a ODAS antenna, a Verizon ODAS antenna on top of a lamppost. Now, you remember we spoke about the outdoor distributed antenna systems and indoor, the IDAS, several episodes back. And I've been researching some of that. And I now know some of the differences between the lamppost additions. Now I know which carrier is which, so I know that I'm nearby a cell. So I'm going to test that theory out probably maybe later this month. I'm going to find myself near a lamppost with an ODAS unit and see how well it works with my Verizon modem, data modem, and see what happens from there. It puts me right at the entry point of the cell network, so you can't beat that, right?
Now, if you remind me something about these ODAS antennas, on the one hand, it sounds a little weird or redundant to say an outside antenna, because that's where most cell antennas live. But with an ODAS antenna, is it the case that you don't have electronics at the antenna, that the RF is distributed some other way, or do you have a full suite of electronics there at the antenna?
No.
It's just a really small site.
You have it's technically a small site. It'd be like probably I think Verizon might call them microsites, and there are electronics in a small box. It's about, I think, 3 feet in height, maybe a foot in depth. That mounts to the lamppost, and above that is an antenna that serves their system. Think of it as just
is it sectorized or is it an Omni?
Oh yeah, no, it's Omni. It's an Omni. The idea is to fill in maybe where a sector would overlap with another and create too much trouble. It's also designed to be used during high peak times. So it's possible that particular unit may not even be functioning when I'm there because it may be not a peak time. I don't know. I'm going to find this out. The nice thing with the modem that I have, I can go into diagnostic mode and look at the SINR, the SINR, and see what the signal strengths look like and if I'm really close or not to that particular antenna. So it should be fun to try it out.
Interesting. So I've not seen anything like this in the Nashville area, but then again, I haven't really looked that hard. So I'm going to start keeping my eyes open on telephone poles, lamp posts also, and see if I see anything like that. Certainly, I see a lot of cell sites on the sides of buildings in a city like Nashville. There's plenty of that.
Sure.
And a lot of times, they'll paint the antennas the same color as the rest of the building to help reduce its footprint. I see them just up the road here at Lipscomb University on their mechanical building, where I guess they have a steam plant or something in there to keep the kids warm during the summer, or during the winter, I should say. There's plenty of antennas there. And, I see plenty of these monopoles that, if you look really closely at the top, you'll see several sector antennas up there. And but it looks, unless multiple carriers are multiplexing into those antennas, they don't have, they're not bristling with antennas sticking out of them like your traditional multi-carrier cell site. Do you know what's going on with essentially a fat monopole with almost hidden antennas at the top only? Is that one carrier?
Well, no, that can actually be multiple carriers. If it's a very thick monopole, though, there is actually one downtown from here by the ballpark. From what I've read, and when they had the sides open, there are actually antennas inside the monopole. So if you're seeing something on the outside, they've probably got no more room to work with, or they've migrated to a new spectrum, and the antennas they need may not fit in that particular structure.
Okay. So it looked like the monopole was fatter than it needed to be structurally. So the outside could be radome.
Yes, the outside is just a non-conductive covering, and inside are sector antennas. Yeah, absolutely. I have passed a couple of those, and there was one not too far from where I am today that I've walked past a couple of times, and they've been working on it. So it's pretty cool.
It is interesting how our society, our world, is depending more and more on cellular that really actually works and works all the time, or works most of the time. And so, boy, we're seeing so much effort put into that kind of coverage, where for a couple of decades we were accustomed to dropping calls pretty frequently. And I got to tell you, in my last couple of driving trips from Nashville down to the Mississippi Delta area in Cleveland, Greenville, Mississippi, I-40 over to Memphis, and then U.S. Highway 61, I should say, on down to the Delta area. I've had conversations on the phone that lasted 3 hours. I'd hang up to go through Memphis traffic and then pick the phone back up again. And the coverage is, to my mind, pretty amazing, even in these rural areas, as long as you're by an interstate. Now, my carrier's T-Mobile. Your experience may be a whole lot better, worse, different, but I've been amazed at carrying on a 3-hour phone conversation.
Oh, yeah, the technology's advanced considerably. The antenna design, the calculations for RF and how to make it work. It's fascinating, the science behind what goes on in cellular technology. And to think a lot of the formulas and a lot of the theory behind it actually originated back in the 40s, in the 30s and 40s, believe it or not. Researching it.
I'd be eager to try out the Google Fi service, which I understand, when it started, you have to buy a certain Google Nexus phone, and it will work. It uses boy, I hope I get these right, but if I don't, it doesn't matter. It wants to use Wi-Fi because that's what OPB, other people's bandwidth. OPB,
right?
It uses Wi-Fi. It uses Sprint as one of the carriers, and I want to say it uses T-Mobile as one of the carriers. I could be wrong, or maybe it's AT&T. But I heard they just added another carrier to that, and I wouldn't think it would be Verizon, since if it's LTE, I guess the tech's not different. Isn't LTE pretty much LTE except for the bands may be different? In other words, it's not CDMA versus GSM, which is a totally different ballgames there.
That's correct. Well, LTE is a derivative of GSM. So if you have Sprint LTE and Verizon LTE and AT&T LTE and T-Mobile LTE, the difference is the carrier frequencies. That's pretty much it. And certain other little nuances, but yeah. And, registering on the network, authentication, all the other stuff that allows you in and out of anybody's network. So
those would be differences that can be handled in the phone software easily, not different chipsets. Because it used to be if you had a phone
Right.
on Verizon, it was pretty much not compatible with anything else. But now that we have LTE, then I guess all the technology is the same or similar enough to where the phone software can accommodate those differences, right?
Yeah, to some degree. I mean, there are some caveats that no, but if I have a Verizon phone that only does Verizon LTE band 13. So if I go anywhere else in the world that band 13 is not available and the LTE is not enabled, that phone is useless.
Gotcha.
But if you have an AT&T phone, they operate on bands. I think it's a 21, 17, or something else, and those bands happen to be I think FDD, frequency domain. No, TDD. No, that's the FDD, and they are available around the world. So you could, with the change of a SIM card, probably use that phone in that fashion. But if you're on Verizon LTE at the moment, you're pretty much here in the States, unless the phone is a multiple carrier. Multiple band. What do they call it? Carrier aggregation software. So, like, say if you have an iPhone, and it works on. I think if you have an iPhone that does Verizon LTE, you might be able to switch out the SIM card and still use, if it's unlocked, and use it elsewhere because it does support the other bands. I believe that's what I read somewhere. So those are the differences.
Well, now for broadcasters, this is it. Cell phone cellular technology is interesting to broadcasters, especially radio broadcasters. I think. Well, TV too, because they use those aggregation devices like
Live view,
live shot, live view, and so that stuff working is important to broadcasters. It lets us do, with a little extra broadcast centric technology, it lets us do meaningful live broadcasts from the field with either high quality audio at decent latencies, or high quality television signals by aggregating multiple channels and even multiple carriers together. So that this technology, the better it gets, the better it is for broadcasters, and it gives us options for going out and bringing news and traffic and live reports right to viewers wherever they are.
Well, just bear in mind though, even though this is getting better, and yes, it's ideal for broadcasters to do aggregating of their data modems to get the bandwidth they need for coverage, you're still relying on a third party that actually doesn't care about your particular business model.
Yes.
I only say this because I've worked at news agencies all my life, so I've run into this problem and these scenarios in meetings asking, what happens if? Here's a scenario that I actually was part of, and thank goodness we had an alternate plan. Covering a major breaking news event at the United Nations in New York City on 1st Avenue and 42nd Street, and our Nextel phones that we use for communicating with the reporters back and forth and doing stuff went down. Now, they didn't go down because we didn't pay the bill. They didn't go down because a cell site went off. They went down because the local law enforcement turned off or put up a jamming device because of what was taking place outside the protest. If it wasn't for the fact that we had alternate RF equipment that was out of the range of the law enforcement's requirement to jam, we would not have been able to do the broadcast that we did, and we wouldn't have been able to get a lot of things accomplished. So fast forward to today, and you're a news agency, say you're television, right? And you're doing video, and you're getting stuff back on your cellular equipment. Well, what happens when you're covering an event that local law enforcement says we need to shut down? Or you're covering an event where the local cell site that you're accessing to get out of that area, because it may only be one cell site, suddenly goes offline because the building it's in lost power or something else. Now, I say this because there's a company, I don't have their name handy, they're actually introducing, they use LTE. And so if you're a TV station or a broadcaster that has access to the BAS channels, the broadcast auxiliary services in, was it 2 gig or 7 gig range, don't give them up because you think they're not useful for your microwave. This company has LTE technology that lets you build your own little LTE video network where you control everything and get the benefits of what LTE offers. Yeah. And I can't think of the name of it now. I've been reading about it for months. And I thought, and I talked to them at the NA bin. I thought it was really nice. I mean, it's not a cheap process, but I'm looking at it from the application and workflow. And if I'm a news agency that relies on breaking news events to keep me ahead of the pack or keep me relative to my audience, it might be worth investing in that technology for my 2 gig or 7 gig microwave link that I have in the city that we use not often enough because it means rolling a truck out. This technology, you don't have to roll the truck the same way anymore because it's using LTE, it's co-FDM antennas. It's pretty cool, and it's something I think people should consider or at least look at, and and it's worth thinking about. Because I'm telling you, if I rely on a cellular phone during a breaking news event, even a sporting event, you better hope that carrier did their homework and are willing to make sure that it's going to stay up for you.
Oh yeah, and what you're saying applies right back to even small-time broadcasters. I say small-time, any radio broadcaster. This is a show about radio tech, so I'd like to bring it back to that. I work for Telos. A lot of Telos customers, a lot of broadcasters use something like a Telos Zip 1, like I've got over here, and then they'll use the Lucy Live or the light version, the Lucy Live Lite software on a phone or a tablet to send their audio from the football game, the parade, whatever, the live remote broadcast at the Kroger store, send that back to the radio station. And you're depending upon the phone carrier to get that done. One of my favorite customers, guy out in California, does high school football games big time, very popular. And they do a long broadcast, sometimes up to 4-hour broadcast to cover a game with all the pregame and the halftime stuff and the postgame show. They do it all live from the stadium. And very smartly, they've got at least 2 different phones on 2 different carriers. And they said that many times they will have to switch phones. One of them will get a little squirrely. But they've never had a problem where they couldn't get on the air because they have 2. I suggested you probably ought to get 3 and see if you can find any local Wi-Fi. And hey, bring a MiFi from Verizon out with you as well if Verizon isn't one of your carriers. Have several sources of internet. And it seems that you and I, Chris, have done several live remote broadcasts of this show, and we've been totally surprised by what worked and what didn't work. When we've gone and done, we did one show with, didn't we do one with data coming from my T-Mobile phone as a hotspot, because that was the only one that had a decent data rate.
Yes, that is correct.
And you never know. I mean, I thought my Verizon hotspot would, typically it's great, but sometimes it's just awful. So you got to have options, and the hotel's Wi-Fi was not good enough either. So it varies a lot. You got to be prepared with several different options.
Well, and the reason I brought this up, and everyone's probably sitting listening, oh, well, I can do this, I can do that. Yes, you can, and you probably will be able to most of the time. But what's going on in the background, and if you're familiar with wireless technologies in the wireless world, there are many different organizations out there that work with the wireless folks. CTIA is one of them. And I was reading up on one of my magazines I subscribe to is a thing called Antenna Systems and Technology. It's nothing to do with broadcast in particular. It's literally talks about antenna systems and their technologies across anything from defense departments to local transportation to broadcast and other stuff. And it's a fascinating magazine with the technologies that talk about antenna theory. And one of the articles talks about something called dual tuning. And it talks about how cell phones are going to have to become even smarter on the RF side. Like if you have the Samsung S, is it right? Is that right? Yeah, Samsung the Galaxy S, the early version, that had 8 antennas in it. 8 antennas in that phone, and they had to operate at different frequencies: Wi-Fi, WiMAX on one of them, GPS, and I think 2.4 and 5.8 gig, and a few other things. And they talked about the technology that went into making that possible. And I thought, wow, that's pretty fascinating. But what's going on now in the world of wireless, and we have to be aware of this as broadcasters, it's very important to understand the infrastructure you're trying to tap into, is that they're doing carrier aggregation. Okay, you may not be familiar with the term itself, but you're familiar with what it can do. If you're using a live shot, live view, or Dejero, or any other popular video products out there that take multiple modems and put them together, that's aggregation. So the carriers do aggregation within their own network. So say you're AT&T, and you have your LTE channel assignments are 10 megahertz assignments, and you want to increase your bandwidth because you need more frequency spectrum to have higher bandwidth. That's Shannon's law and a few other principles involved. You need to aggregate them. So now you want to do 2 or 3 10 megahertz channels to get 20, 30 megahertz, whatever you need for aggregation. But what the carriers have discovered is they're more focused on making sure the downlink is robust. The downlink is where they're putting the energy into making sure there's reliability. Just as you pointed out when you made your phone call for 3 hours, the downlink is where they're focusing. So what does that leave for us broadcasters who need the reverse?
Yeah.
See, and the reason they're focused on the downlink is they control it better. The downlink is controlled from where? A fixed location. whether it's an outdoor antenna system, a cell site on a pole, or something in a building. Whereas the uplink is you and I. We're on the phone. Our little phone device is basically, it's a variable they can't control very well, and they need to advance the technologies, and that's what's happening. So think about it. When you're doing your broadcast and you got your phone set up on the table with a hotspot built in, and why does it not work as well as the other guy who may be using a data modem plugged into the USB port? That could be the reason. Because the cell network you're connecting to, the infrastructure has been optimized for the downlink side. As we've said before, always check on these sites, look at where you're going, and make sure you understand what you're getting into, because do not assume, just because you can make a phone call from that location, the data connection's the same. Voice is still going over 3G part of the network, not LTE.
God, there's so much
VoLTE has not come out yet.
Yeah. Wow, there's so much.
I mean, it's out there, but it's not 100% penetrated.
Right. So much that I don't understand. Is it as we move forward? Is it likely to get better and better? It seems to me it is, but
yeah.
Okay. All right.
Yeah, it just bear in mind when we're doing a connection for broadcast, we're doing a pegged up, it's an up all time connection. Most cellular networks aren't looking at continuous, I'll call it continuous data streams. They're thinking bursty. Phone calls come and go, they get dropped, they get handed off. There's a lot of room with making a phone call and voice traffic being shuffled around. When you're doing a broadcast like we are, where it's a synchronized link between two endpoints, it's a little different. You on your phone, you may not hear it, but there are times when the audio drops or mutes or just, it goes in a different direction just momentarily, but your brain compensates for that. Be very, conscious of that. But when you're doing a broadcast, there's no compensation. You're listening to a feed coming to you, and hey, I just heard a dropout. I heard something go wrong. It's very different.
Man, it's a different, it's a different world. I mean, 20 years ago, we were all using Marty's to get our broadcast back. And that was
I was at a radio station a couple of weeks ago. Yeah. They still use a Marty.
Yeah. And hey, if you got the people to set it up and you got good shots, it's beautiful. It's a great thing.
Yeah. It's funny. They actually told me they use it in places where their Wi-Fi hotspot from this carrier service doesn't work.
There you go.
I thought it was great. I'm like, look at this. You would think it'd be the opposite.
We've got more coming up in a few minutes. Hey, I got a nice notice yesterday. The latest Radio World is out. There it is. Just came in my mailbox today when I got back from the SBE meeting, and
shameless plug alert.
Yeah, turn to page 26. There you go. It's yours truly with a climbing harness.
Yes,
and an IP radio. So it's my little article. We've talked about it enough. I don't need to go over it. But if you've missed what I had to say in relating my experiences with real world building an IP radio STL system, actually two of them, then you can read page 26 of the latest Radio World magazine, and I describe them. And we've had in the article, I believe, I wrote this some months ago. In the article, I believe I say, we haven't heard any problems with it. Well, we have heard a problem. And we're going to tell you about that in just a few minutes, so hang tight. Our show, This Week in Radio Tech, with Kirk Harnack, me, and Chris Tobin. It's episode number 314. We've got more to come on the show. We're sponsored in part by the folks at the Telos Alliance, and instead of talking about a product, I really want to talk to you about an email newsletter. I know you get a bunch of email newsletters already. How about one that's valuable, that actually gives you some information that, is helpful for you? You're going to have a meeting tomorrow with management. There's information here that'll help you out with that. You want to get a chuckle about something in old-time radio or something just from a few decades past, or a milestone that the industry has crossed, or maybe in your engineering career that you've crossed. It's in our newsletter. The Telos Alliance puts out a weekly newsletter called Direct Current. We have an employee, a guy named David Sarkis, who is just about full-time on putting this newsletter together. And you just saw a brief look at one right there. That was actually an older one, but the one that's on, the one that's out right now, I thought I had a copy of it here handy, but where'd it go? Here it is. Yeah, in this week's newsletter, we've got a link and an article about downloading the latest Omni 11 software. It's version 3.0. Do you have an Omni 11 processor? Do you know someone who does? Well, right here at the top of the newsletter. This is the way we get the information out to you about how to download that for absolutely free. How to get support 24/7. It's got another article leading you to understanding more about streaming from our 14-part Streaming University series, all about CDNs, content distribution networks. You want to know about how to choose one, what different kinds of CDNs there are. It's a quick video on how to understand CDNs. And then there's a video remembering Charlie Tuna, very famous announcer, fantastic guy, a real giver in the industry, did a lot of charity work, passed away at the age of 71. And there's a soundtrack here back from 1974 from his days at KKDJ 102.7. So we have a link to that as well. And every issue, we've got, I guess, what you'd call a kicker story about radio that will make you chuckle. And then other things that'll, inform you and keep you up to date on what's going on, both in the world of the Telos Alliance and the radio industry in general, especially audio technology and audio over IP technology. So check it out, Direct Current. We'll put a link in the show notes, but you can go to the website. You can go to the Telos Alliance. Just go to telosalliance.com. And under, if you mouse over the area called Contact Us, every website has Contact Us, a little pop-up will occur. You can click Subscribe to Direct Current. And, of course, you can unsubscribe anytime. We follow all the rules on that. And just give us your name and email address and country. Your phone number is optional, not required, and click subscribe, and you will get Direct Current. I think it's valuable. It should be in your inbox, and it's a good thing to just peruse for a minute or two or three every week when it comes in. It goes out on Thursdays, the day we do This Week in Radio Tech. Where do you think I get my material from? Thanks a lot to Telos Alliance for sponsoring This Week in Radio Tech with Direct Current. All right. Chris Tobin, we are talking about, I guess, a little bit of the summertime blues, and one thing that kind of made me blue, we were talking about IP and radios and kind of high-frequency stuff. And in this article in Radio World, where I, page 26, where I talk about our IP radio STL system, we did this because it was inexpensive, really cheap to do this. Our major cost was an Axia X node, which costs, a little over $1,000 street price. And the radios were cheap. The cabling and surge suppression cost as much as the radios did. We've had a couple of dropouts. And interestingly, the chief cause of dropouts was, believe it or not, sun fade. Sun fade. Now, we're all used to sun fade occurring on our satellite links, right? Because twice a year, the equatorial belt where the satellites are, the stationary satellites, as the Earth moves around the sun and the tilt and all that, you'll get the plane of the ecliptic, and you'll get the sun ending up behind the satellite you're trying to receive. It'll transit that for a few minutes every day for a few days as the sun, the Earth moves around and the position changes. I never thought about that occurring on a terrestrial microwave link. And yet our link is aligned such that the transmit receive dishes for the Ubiquity 5.8 gigahertz link at the studio, it's going to happen twice a year. It's looking right into the sunrise, which occurs technically, I guess, behind the tower at the transmitter site. So it's looking just a little bit north of east. And so during the peak summertime, around the end of June, when the sun is actually rising a little bit north of east in the northern hemisphere, because the Earth's tilt, the sun transits right behind the tower, and the dish at the studio is looking smack into the sun.
See, your tower is a geostationary satellite.
Yeah, it kind of is, isn't it?
It's exactly that. That's exactly what it is, just here on terra firma, that's all.
Yeah. Well, and so you did a little research about sun fade. And I think, does the sun emit energy in the 5.8 gigahertz area? Because we're on the unlicensed 5.8 gig band. we're also in a part of the band where Ubiquiti let me turn the radios up to the highest power level. I know there's different rules for different parts of the band. There's a warning in there that, hey, you may be on the same area that NEXRAD radars are in. And so, in fact, you can map where the NEXRAD radars are across the U.S., and they said you might not want to pick a NEXRAD frequency if you're near one of those. And out in the Mississippi Delta, where our stations are, we are many miles from the nearest NEXRAD facility. So that's not a problem. So I picked an area where the software let me turn the radios up to a screaming output, a good 10 or 12 dB higher than some other parts of the band. It let me choose. And anyway, but yeah. So what did you find out about sun fade and 5.8 gigs?
Well, I was, as I mentioned to you, well, speaking of NEXRAD also suffers from the same thing you talk about. So with their spikes. But I was reading up, and it turns out that there's a lot that goes on in the sun fade, or I guess what we should call solar noise. And there are a lot of systems when you're pointing your antennas in a direction facing the sun, or they wind up facing the sun depending on the rotation of the Earth. And there are tests people have done, and there was an article in the Antenna Handbook by Joe Carr, I believe is the name. And he cites the fact that you can test this theory of solar noise and whether or not this truly exists by taking a directional antenna, usually in a VHF, UHF frequency range, or even microwave, pointing it directly at the sun on the horizon, and then watching your receiver noise flow change as the sun crosses or transits the path of the beam of the antenna. And apparently it's quite a popular issue, and it's something that microwave path designers have worked on and have experienced for years. Matter of fact, there was a brief article I found from, I think it was AT&T Labs. The early days, back in the 40s, they were just discovering that the solar noise issue and noise in general, what it did. And that's one of the reasons why the Earth station for GE Americom, or now SES, is up in Vernon Valley. Because back in the day when they built that uplink facility for this, when they fly the spacecraft, they had to get away from a major noise source, which happened to be a small place called New York City. When you have these 11-meter dishes that are the size of a building pointing up into the sky, trying to hit something that's 22,000 miles away, and the noise floor is measured at like minus 200 degrees Kelvin. Yeah, you don't want to be next to a big urban center trying to listen to something that far away.
That's a good. I wondered why those uplinks were away from from New York City, and that's why. That's one reason. A lot of the legacy uplink facilities, some of the big ones, and they're still in use and still do a lot of crazy stuff. It was primarily for noise. They had to get away from noise sources, get a noise floor that they could work with, and that's what they had to do: physically move. It wasn't just a question of the technology; it was physically move away. So you and I were talking about, is there a solution to my problem? Because we're going to have this twice a year. We're going to have sun transit behind the tower, and we're going to get this. And apparently, and I haven't fully investigated this, but of course, we're sending data. We're sending axial live wire streams over this to the transmitter side, and that direction's not the problem. It's the return direction. But the radios have a lot of stuff going. They're chattering back and forth between themselves. And apparently, if you lose the chatter in one direction, that is from the transmitter side back to the studio, then the other direction is not reliable or doesn't work or stops or something. Again, we just put up a syslog server. We're going to log all this stuff so we can see, try to get a handle on, what's going down exactly when. We won't have that problem again until I don't know when. It may only happen for us once a year, not twice a year, if we're just happen to be at the extent of the northernmost extent of the sun's rising in the northern hemisphere. So I'm not sure if we were. I don't think we experienced that twice. I think we just experienced it once. Anyhow, how can we solve this problem? And I'm not sure that we can with that path. We have to come up with an alternate means for getting audio there during those outage periods.
Well, maybe a similar wireless link between the two sites at lower on the tower, or maybe antennas with a very, very pencil thin beam width that maybe you could get some of the noise floor out of it, because the ubiquities you have now are pretty not wide beam width, but they're probably large enough that they can see a lot of the spectrum of the sun.
Well, and here's the thing. We still have a 950 megahertz link. Of course, that's one direction going from studio to transmitter. We still have one up and running. It's running one of our stations just because we haven't taken the time to move it over yet, because the audio for that station is appearing at the transmitter site via the IP link, but we just lazy, haven't moved the processor out there and the baseband over. And of course, that's unaffected, because it doesn't matter. It's the antenna, the 950 megahertz antenna, isn't looking at the sun. The sun's exactly behind it at this point when the others are off. So we may just try to implement, a digital 950 system where even if we got 4 monos, we'd have all 4 stations out there as a backup with 4 mono streams, 4 mono programs.
Or you could do a IP link that doesn't require symmetrical syncing and just have it work in one direction.
Yeah, in fact, the Ubiquity may offer that. So I'm just not sure if that'll be the case. Although that needs to be there pretty often for Livewire, because Livewire talks back about yes, I'm subscribing. Yes, I'm getting this IGMP group. Yes, I'm joining or leaving that IGMP group. So I think two-way is pretty important for that. But for other kinds of streaming, it would not be. So anyway, it's going to be an interesting problem to solve. I'd like to solve it by having a separate path altogether, so I could do work on the IP link if I needed to. In fact, at some point I need to install the second Ethernet cable so that I'm doing the monitor and control, the M&C, over a separate connector that's available on the radio. Right now I'm doing both M&C and data on the same connector, which is perfectly allowable, but it leaves you with less flexibility to control, and you can't do data trunking from, say, one Cisco trunking port to another Cisco trunk port. So I got to solve that. So anyway, it's up and running now, but it's an interesting problem, and one that I didn't expect to see at all.
No, I think that's pretty cool. That's pretty fascinating when you think about it. You take for granted these little subtleties of linking and STL paths and looking back and forth. And when you do an STL path, you're always worried about interference from somebody from another radio station farther out on the compass point of where you're pointing to and from. And yet you got the one big one that just moves around all the time. It just every so often gets in your way. And there's not much you can do about it. There's no coordination with that particular user.
Yeah. So what else was on your list? I had one more quick thing. Since we're on the subject of data, Ethernet, and all that, we'll bring it back home into the into the radio station. So on our business network at our Greenville stations, and this may be advice that other engineers need to hear. We've got all of our business devices and our Rivendell system, not the Axia side of Rivendell, but we've got the file sharing side of our Rivendell system all talks through the same business network, although the Rivendells are on their own switch, which ties back to the business network. So the Rivendells have, remote access, and they can get NTP time updates and things like that. So the Rivendell machines depend on having a completely persistent file share with the server. They're playing music basically, off files on the server. The individual workstations are. And once in a while, they'd all disconnect. And we had 4 stations off the air when they would all disconnect. 5 now, actually. We had 5 in one building. And so we were scratching our heads over this. Why can't, and we go back and reboot them or reconnect them, and bam, there was the file share from the server. Worked fine. But why would they disconnect? And we had an unmanaged and rather inexpensive Ethernet gigabit, though, supposedly gigabit Ethernet switch that these Rivendells were all tied into. And it doesn't matter the automation system, I suppose. It could be any of them. These are all Linux machines looking at file shares. And what we noticed was, what we decided to do was, what if the problem is the switch? Honestly, the switch is about the cheapest thing in there. It was like a 16-port gigabit switch. By the way, gigabit meaning that the ports are gigabit, but the switch fabric may not be able to handle all ports busy at all times, and they may be dropping some packets. We didn't know. And unmanaged switch, a little hard to get much stats out of it. So we just decided to switch over to a better switch. And some of our support guys at Telos suggested an inexpensive range of Cisco switches. And I'm sorry I don't have the model number right here real handy. I'll find it and put it in the show notes. But it wasn't expensive. I mean, 16 or 24 port switch was under $300. And it was a managed switch. Not a switch qualified for Axia Livewire or perhaps AES 67, but perfectly usable with about any business thing. Anyway, long story short, replacing the cheaper switches, and I think they were trend net. That may not matter. They were just a little over $100 gigabit switches. We took those out, put in these Ciscos that were about double the cost, but still fairly inexpensive. Certainly didn't break the bank. Problem gone. And I'm thinking it's because the Cisco switches have a better ability to handle, ports being really busy and lots of throughput at any given time and handle bursts like that. Chris, did we solve the problem by replacing the switches? What are your thoughts on our results or what we did?
Absolutely. The difference between a managed switch and unmanaged switch is just that, how it handles the data. Networks can get congested real fast because we use them as a backbone. It's like a highway, and people want to get from point A to point B. And if the fastest way is on ramp A, then they're all going to go to ramp A, and then all of a sudden there's congestion. And how well you can get on and off is what a switch does. And I've used unmanaged switches in many applications where probably shouldn't have, but the traffic was minimal, so we didn't stretch it. But recently I've been working on a couple of projects, and I've had to go to small managed switches, real simple ones. They don't have to be super duper, the old 2960s that people are probably familiar with, the Ciscos, but something that you can control what the port does, how it does. The nice thing too with a managed switch, if you get the right ones, you can do mirrored ports. So you can actually see what the traffic looks like, what's going on by mirroring the port to another port. Then you can keep it on the healthier network. So there's a few reasons why you should be looking at managed switches. But yeah, file shares. File share is a connection between two Ethernet points, and they have to stay connected. If they get disconnected, they're not intelligent enough to know what to do, unless the software says, "Oh, I've lost my connection," and I restart. But most of the time, that's not the case. So yeah, unmanaged in a switch that's $100 or $69.99 switches, and you're putting it on a network that's very busy, I would suspect 90% of the issues you're experiencing with the other software is most likely the switch you're going through.
I found the switch that we got. Again, this was highly recommended by some of our techs at Telos Alliance, not for an Axia, not for a Livewire qualified switch, but as just a really good business switch. And it was the Cisco SG300. And we happen to get the 28 port version. You're familiar with that one then, the 300 series?
Yeah, nice box.
There's a 10 port version and some other versions as well. Those are managed switches. We actually, I was told, and I couldn't get to the studio site to put these in myself, so I had some less technical people put them in. And my colleagues at Telos said, "You're just using this for a business purpose. You do not have to configure these switches in any way. Just pull them out of the box, plug them in. They'll be fine for business. If you ever do want to give them, go into them and give them an IP address and set up any little management you might want to. Great, fine, but you don't have to." And so we had some non-technical people swap them out, and problem gone. So there you go.
Yeah. And also, don't get caught in the trap of putting a switch to a switch to a switch to extend your Ethernet in your building too.
Oh yeah, don't do that. Yeah,
I got burned on that a couple of times last year with a friend of mine helping him out with a project at his internet radio studio. Actually, TV radio studio, and he was trying to explain to me, "I don't understand. We're having a problem with this one studio in this part of the building, and we can't figure out why everything goes great until all of a sudden we turn on the video and blah blah blah." I'm like, "What? What do you mean?" And so, looking at the network, doing Wireshark and looking at some of the switches he had were managed, I was like, "All right, let's look at the switch," and I noticed I was like, "Wait a minute, where are these packet errors coming from? Why am I getting these packet errors that are like showing up out of everywhere? It's just like broadcast all over the place." And it turns out that to get to the other part of the building, somebody decided to use an Ethernet switch. Like you say, it's a gigabit switch, so it can handle the bandwidth. And they cascaded, I think, 3 switches. And the quality of the switch was okay, but it's just the concept, the principle behind Ethernet collisions and all the other, there's the OSI layers, all the stuff that goes on in Ethernet. I'm not going to get into the details. Those who do this for a living know exactly what I'm talking about. And it was just like a mess. And I said, how about we try this? We just ran one long cable to that side. It just happened to be well within the Ethernet spec, so it was okay.
Yeah.
Ran it down the hall. I said, I just unfurled this roll, put connectors on it, and I said, let's try the same thing now and see what happens. Guy goes, wow, the video looks great. The audio sounds good. We're not dropping frames. I'm like, really? You're killing me with this. I was like, all right, now it's time to pop the ceiling tiles and let's go from closet to closet, get this cable down there. And he looks at me, he's like, that's it? It was that simple? And I was like, yeah, I guess in those terms it is. But it goes back to what you and I have always talked about on the show and said, try and learn, understand the foundation of what it is you're working with. Like I'm using the webcam, and now the sun's moving in front, so now the light's going to be really bright and probably clarity is going to change. But it's like learn, understand what's going on with that and say, okay, how do I use it in my application? Or, you're doing air conditioning for a studio. Just don't buy it because it's a 5-ton unit. Buy it because 5 tons based on the BTU load of the room and the potential, changes in the room. Say it's a studio with 1 announcer and 1 guest. Well, what happens if you decide to bring a band in? Now you've got 5 100-degree heat generators in that room. That's right, the human body, 98.6, 100 degrees. We forget that part. So you work.
You remember though, band members are cool. They're cool.
All right, it's cool, but you know what? It's still a hot moment when you have that cool moment.
Right.
So it's like,
and they're all working.
Yeah. So people overlook that. And I remember working with a design company. We were doing. I was brought in to do RF, and then they brought in some folks to do studio acoustics, and then the heating and cooling systems. I was working with the air conditioning guys, and we were talking, and the guy looked at me. I was like, okay, we don't build many studios. We do a lot of data centers. So I said, he goes, what is the load in the room? I said, well, you tell me what you consider loads. What are the devices or mechanisms or instruments that you... So he starts saying, well, computer, server, and then he pulls out a chart, and all these devices have a set industry reference point. Like a desktop PC could be roughly 500 BTUs. It's standard. Yeah. A server could be maybe 1.2 kilowatts of power. I'm just randomly doing this. I'm not saying this is the number. Then he said, well, we don't factor in people, but you're going to have people in here, right? I said, yes. Oh, well, okay. Then we have to figure out the change in temperature when the people are in the room, when they leave the room. I was like, whoa, okay, wait a minute. What are we talking? And all of a sudden that 3-ton unit they spec'd started creeping, increasing in size. And all of a sudden we wound up with a 10-ton unit, and the guy did the math. And I was like, wow. Now, I said to him, what happens if we didn't do it this way? He goes, well, you'd probably run into the room never cools properly, people complaining that they're not comfortable, and you're probably going to have 10 extra visits a year for your service calls because your compressor, coils, everything else will be stressed. And I was like, wow. And talking to more folks that do this for a living, HVAC, they told me, they said they've worked in many a building, businesses included, not just broadcast, where they didn't pay attention to those details. And service calls were a regular thing, or compressor changeouts were happening more often than they should.
Wow.
So and Ethernet switches, same thing.
If a desktop computer is generating a 500 BTU heat load, some number of watts, whatever.
Yeah, 500 watts, something like that. Yeah.
That's a dry heat. A human body not only puts out heat, but puts out moisture too in every breath and sweat, and that moisture adds to the latent heat in the room.
Yes.
Yeah.
Yeah. There's a whole science behind everything we do in broadcast. You just have to be willing to take the time to learn it, and once you do, that's when you have the best thing. It's like I worked with, over the years, I've had the pleasure of working with a design company that does a lot of work for broadcasters, Meridian Design. They're based here in New York City. And those folks, when they build a facility, and I can tell you this, and if you work with them, and there's another company that does furniture, studio furniture and layout design called Studio Technology, and the proprietor is Vince. Those two companies, I can tell you, I've walked into a facility, SNY in New York City, Sports New York, the TV sports station in New York City. I walked into the studio one day with a friend of mine who happened to just be fixing their wireless mics. I walk around, I'm looking, I see the doors and the window layout for the studio glass and the furniture. I talked to the engineer. I said, did Meridian Design work with you guys on this layout? And they're like, yeah, how'd you know? I don't have to say a thing. You could see their handicraft. And I went to a radio station, happened to be, where was it? Was it Washington? no, it was Washington or Syracuse, and the furniture layout and the whole design, the cabinet doors, the way they open, and the ease of access for the engineers and even for the operators in the studio technology, at Vince. And the guy looked at me, how did you know? I was like, you could tell by the handiwork. It's just like people who do Cisco work or HP Pro Curves, and you know why the network works as well it does because of that particular branding or mark. And that's the key. If you can get your head around that, just like your ubiquity stuff, that is, same thing. Once you understand it, you know what the limits are, you put it to work, and you should have trouble-free moments, except for when the sun gets in the way. But other than that, it's only a rare occasion.
I think a good touchstone, a good advice for us as engineers is, if we're guessing how to do something, maybe we ought to ask. And that's something that I have done not often enough in my life, is just go ask somebody who does know about such things. And we gave a great example on last week's show. A couple weeks ago when Mike Patton was on, and we were talking about the latent heat that comes into a transmitter building if you're drawing in outside air, which is moist. And in the southern part of the U.S., it's going to be moist all summer long. And so drawing in that, you're not just drawing in heat, air that's 96 degrees during the middle of the day. You're drawing in air that's 96 degrees and contains extra heat because it's moist. And that water all has the latent heat in it. So you really have to do a lot more cooling. And as Mike Patton pointed out, you have somebody who knows. They did the calculations, and it is not much more expensive in terms of electricity and equipment to constantly cool, to have a closed system where you're cooling the hot air from transmitters, because then it all stays dry if not pulling in outside air, versus having an open system where you're cooling outside air that's coming in, running it through the transmitter, and blowing the hot air outside. And knowing that, the decision was easy. Let's spend a little bit more money and have a system that is pretty much free of dust and doesn't have all that latent heat coming in, and is overall just overall better on everything. And two air conditioners in case one fails. Either one can take the load for a while the other one's getting fixed. So, Chris, are you back?
I'm back. Yeah.
Okay, good. Hey, we got to take a quick ad for a second, but one more little quick thing I want to mention. See if you had any more thoughts about this since we chatted earlier. I have noticed, actually, a friend of mine pointed out that some TV stations, maybe in smaller markets, are doing something interesting. There's a market. Well, it's not a secret, I can tell you. It's Greenwood, two cities, Mississippi, where you've got an ABC TV affiliate and a CBS TV affiliate, now co-owned. And for obviously, while they were separately owned, and even for a while they're co-owned, two licenses for two TV stations transmitting from two different towers. Now, one of those licenses is going back to the FCC, going to get sold off in the reverse auction, and that affiliate, that CBS affiliate, will be transmitting on the ABC affiliates, one of their secondary channels. So you'll have I guess, I don't know what channel they're actually on, but you'll have a 6.1, which will be the ABC affiliate, and a 6.2 channel, which will be the CBS affiliate. And that's kind of an interesting concept. Now, so what the upshot is, the old license, it happens to be channel 15, gets turned in, and it may actually be a higher channel. I don't know. It was billed as channel 15 over the air. And now their tower is going to be unused. They've got this 900-foot piece of steel out in the middle of a bean field, and they're not going to be using it anymore. So interestingly, maybe an opportunity for radio stations, if you need a place where there's a tower, and there may be some vertical real estate come available that hadn't been available before for lack of necessity. People want to keep their tower simple, whatever. It's interesting there. With these channels getting turned into the FCC, these TV channels, I didn't realize that a possible way to still transmit was to be on a co-owned digital subchannel. Thoughts on that, Chris?
I think it's a great idea for many applications and the way things are going in the industry. I mean, ATSC 3.0, I think, is somewhat, it looks in those lines with being able to do IP transmission and do multiple programs and all that stuff. The model is changing. broadcasters have to find a way to get the story out to the audience, and if the two stations have combined and now co-owned, or the affiliations under one umbrella, and the signals can be still co-opt and people can still enjoy it, then and so be it. It makes sense. In urban centers like, say, New York City or Philadelphia or Boston, it may not happen quickly because there's probably still a lot of territorial things that can't be crossed over, and affiliation contracts vary from market to market, so who knows. But as I'm discovering, talking with folks and traveling about, people don't really care too much of the old model of who's affiliated with whom. It's more of, is that the show I want to watch? Yeah. It's like if you have a digital tuner on your radio, TV, and you can tune in to, say, your local channel 5, we'll say, just TV5. It's 5.1, 0.2, 0.3, 0.4. So what? Is 0.4 have the program I want? So be it. And that's what's happening. Now, the trick is, can you move that along to wherever they go, rather than have to be at their house or at the desk? Can they get it on their computer? Can they get it on their phone? That's the other side of the equation.
The world's changing, and owning that spectrum real estate. Well, these two are co-owned, so obviously they can do this and save themselves a ton of money every year from operating a separate transmitter and tower site and the liabilities there. Although they don't know if they have plans to take the tower down, that costs a lot of money too. But since they own the channel 6 or whatever it really is, they can put 2 TV stations on there and I guess it's at 720. Quality, or whatever it would be if you split up in 2. So interesting. The times, they are a-changing. Hey, Chris, we got to take a quick break, and we'll be back for maybe a little tip if you can work one out for us. I've got a little tip myself. I can't remember if I showed it or not. Maybe I already showed it. I'm not sure. Hey, our show is brought to you in part by the folks at Axia and the Axia Fusion audio over IP console. Folks, I was just in a radio station a few days ago that had this console, and they did have the older Element consoles, and they swapped out to the new Fusion console. Then they took their Element and put it in a new studio that they had. That's a station right here in Nashville. And I talked to the program director. So, how you guys adjusting to this new Fusion console? She said, we love it. It's so easy. It's just like the Element console. It's a sharper, new, updated look. We love it. And did anybody have a problem, getting adjusted to it? Nope, it works fine. And what she doesn't know, and what the engineer does know, is the Fusion console has a lot of power under the hood. And when I say that, what I mean is, if things that we as engineers used to do with little external boxes, maybe we used to call them a Diddy box, or a blue box. We need to mix these 2 channels together, or split this, or add a back feed into this feed, and so we can send it out here. All that's built in. All that's built into the Fusion console. There is so much mixing logic in there that you can define a source. Let's say you have an ISDN line coming in, or an IP codec, whatever it is. Let's say it's a codec. And you go and do live remotes. And sometimes, if you've got your morning crew out there and you do a really full setup for a live remote broadcast, when you are actually taking a back feed from the studio and piping it into PA speakers there at the live remote site, so that people can hear a non-delayed, if you're an HD station, you got 8 seconds of delay on the air. You hear a non-delayed out the PA speakers. The announcers on site can talk locally, or they can talk, in the broadcast. And to have all that work, to have the back feed split left and right, so that you have one channel is the feed for the speakers, and the other channel is a private back feed to the announcers from the station. That can be a little complicated to set up. Well, the Fusion console just handles it like that. It's got setups for all these kind of things on a per input definition basis. So you can define that codec to do all those fancy things, that fancy backfeed, if you want to. And you can define the same IP codec or ISDN codec to operate maybe how you normally do. Have a mono feed going to it, or a stereo feed that is interruptible, from the talkback button on the console. In other words, you can have it work different ways depending on how you want to use it. And the definitions just stay in the console. So when let's say the morning board op comes in and the morning show, the morning crew is doing a live remote broadcast from, let's say, Universal Studios in Orlando or wherever they might be. If they want to have that fancy schmancy split back feed, one side being interruptible, the other side not, you can do that. Literally, the board operator just brings up the correct definition, the codec defined the right way, and bam, it's done. And I'm just describing one feature that was added from the legacy equipment and into the Axia Fusion console, and it's there. And you can do the same kind of thing I just described. You can also apply all that to the recording bus, so you could have recording automatically of so many things in different ways, whatever you need. You can split left, right. You can have the announcer be part of the recording or not. You've got maybe traffic calling in. You've got, who knows, maybe you got Robin Meade from Headline News calling in and giving you some headlines like they do on America's Morning Show here in Nashville. And this just works automatically. It's just amazing what you can do with this console. No more blue boxes, no more Diddy boxes. Just do it all with the programming in the console. The Axia Fusion console, hey, remember now it has LiveWire Plus, so it automatically includes AES67 to make it easy to connect to other things, like maybe some Genelec speakers, just over Ethernet. Check it out. Go to telosalliance.com, click on Axia, and look for the Fusion audio console. Thanks a lot to Axia for sponsoring This Week in Radio Tech. Okay, Chris, we just got a minute. You got something for us, tip-wise?
Sure. Hey, it's regarding remotes and outside broadcasts. How often do you try to set up for a broadcast, grab a case, and realize I'm missing a few things? Something to ponder for the upcoming season of events, whether it be sports or spoken word for the fall. And this is something I've done over the years, and it's worked very well. And I've actually watched people still use the stuff I built 10 years ago, so it's pretty cool. And they're little kits, remote kits. So say you do remotes on a regular basis, they're sporting events, whatever. Put together a Pelican case or a Storm case, whatever brand you want to use. Put the gear in there that you use for those events and leave it there when you come back to the station. I know it sounds simple, but you know how many times people do that? Then they raid the case and all of a sudden they go back out to an event 3 weeks later and go, where are the headphones? Oh, yeah, we needed them for recording in the production studio.
Yeah.
I can't tell you how many times I've worked with folks who have done that stunt, and I'm like, really? You do this on a weekly basis and you still don't get it. Give it some thought. Build the kits, whether it's a mixer and a codec and 3 headsets, 3 mics, whatever it is you do, keep them together. Trust me, it pays off in the end. Because I just did an event the other day, and because we do this thinking, I was able to grab the case with the mixer, and in the case was 4 mic cables, the 2 mics to go with, power cord, an extension cord that is, and then I was set to go. I was able to set up and pull everything out, and then pull out the other road case with the gear for the music we were doing. Real simple. Within 30 minutes, we're up and running. So this is the kind of things you got to think about. So the tip is build a remote kit, make sure it stays intact, and even actually you could do a studio kit as well if you're a place that does performances or you do a lot of sporting stuff at the station or even music. Give it some thought. It makes a lot of sense to have a kit available and just leave it as is. Just don't think you have to take it apart.
Yeah.
Put it aside. It's important.
Lock it up. Lock it in the closet. Put a padlock on the Pelican case, and well, that's a great idea. Quit raiding these things.
I worked at a sports station. We did sports events all the time, and we had a closet full of these little road cases. They're handheld. I call them taxi friendly because you can take them in a taxi. And in those cases was everything you needed to do a talk show, sports talk show, at least 3 with a host and 2 guests. That was the minimum we needed to have. And I kid you not, there were times somebody would call up, "Hey, so and so wants to be able to do a show this afternoon with interview so and so. Can we do it?" Go in the closet. Yeah, we got a kit. Off we went. Within 10 minutes. The answer was yes, programming was happy, and they were able to make the event happen. And guess what? Oh, sales was able to sponsor it. Money was made.
One of my favorite people in the world is a broadcaster. He owns some stations here in Tennessee. His name is Paul Tinkle. He's on the NAB board of directors and just a great guy. Paul tries to make things really easy, simple, and foolproof for his DJs, people that go do remotes and sports broadcasts. He does what you said, build a remote kit and keep it intact. Once the kit is built, he takes a picture of the stuff in the kit. I've done the same. And then he prints that picture out and pastes it to the inside of the lid. So you open the lid and there's a picture of what it should look like inside.
Yeah.
Pretty
Also,
smart.
make sure you label all the content so that each kit has a number. So when somebody decides to mix and match and take something out for a studio and you find it, you know exactly where it came from.
Ah, okay. Mic 3, Kit A.
Yeah.
Good idea. Okay, here's my tip real quick. You know, a lot of engineers are putting IP cameras at their transmitter sites, right? Well, maybe you have a transmitter site that still doesn't have IP going to it. You don't have an easy way to do that. Or you just can't afford the $100 to $200 price for, you know, a drop cam or, you know, similar. And I know there's some cheap ones out there, and the cheap ones do have some security issues typically. Here's an idea. No security issues, but you can still get video if there's anything squirrely going on at your transmitter site. This is one of those it's called an auto DVR, right? It's supposed to go on your windshield in your car. Well, these typically have a motion detection. You know, they can be on all the time. So power it with USB to the wall or to a UPS, and put it in its mode where it doesn't record a thing until there's a change in the scene, right? And just mount it somewhere in the transmitter room and tell it to record on motion. And you know what? You get back to your transmitter site and you can, hey, we went off the air, Thursday. Or I wonder if somebody in my shared transmitter site was in there. Or what did the telco guy do while he was in there? Well, you got a record of it right here with your dash cam. And these things, honestly, you can go to one of these websites like wish.com or geek.com. You can buy these for $12 now. They don't include the memory card for that, but you can add a memory card to it. And they're cheap. They're not great, but for $12, you could put 5 of them in your transmitter site for $100, and then you've got a record anyway of what happened while you weren't there. You might put one outside, put one at the base of the tower, put one where you think shenanigans may be going on, and they're cheap. You go back and review the tape and see what happened. Chris, thanks for your participation today. I really appreciate some of the good ideas that you had and thoughts about LTE and cellular and all that stuff.
Oh, yeah. Just plan ahead. Just be sure to plan ahead. I learned that from folks, Wally Linux up in Canada and Paul Sanchez in New York. These are folks who watch us and are entertained by what we do, but they've taught me a lot over the years, so I'm just giving them a credit for that. So a lot of what I understand is from people like that, mentors who've been through it before me. So just got to give a shout out to those folks.
Good deal. Thanks, Chris. And thanks a lot to Suncast, who's producing this show, and to Andrew Zarian as well, the founder of the GFQ Network. Tell your friends about This Week in Radio Tech, if they're radio friends. Just tell your radio friends. Appreciate the sponsors, and we'll see you next week on This Week in Radio Tech. Bye-bye, everybody.